So in this next section, I'd like to start out with sort of a basic high-level foundations for networking, because as I mentioned, this course is developed starting with just the home user in mind, someone who has no idea of what networking is. When they open up their browser and something goes wrong, they have no clue as to where to even start. So let's just cover some of the real high basics of networking, and who knows, after going through this section, some of you guys might say, hey, you know what? That sounds like an interesting field. Maybe I want to go into that. Might spark some interest for you. Okay, so first of all, this term, what is networking? Networking is basically just the exchange of communication between two devices. That's it. You know, as a matter of fact, networking existed long before Cisco existed. You know, think about way back in the day, you know, a lot of you guys have seen movies where, you know, the American Indians out on the plains used smoke signals to talk to each other, right? They were so far away they couldn't see or hear each other, so they used smoke signals. Well, guess what? That is a form of networking. You know, you're trying to communicate with someone who you can't talk to, who's not right there. You have to figure out some other medium or mechanism to convey your information. That, in a preliminary sense, is networking. Now, computer networking just gets a little bit more complex than that. Okay, so the software, the applications in your laptop, you probably have lots of stuff in there. You've got iTunes, you've got, if you're running Windows, Notepad, Word, PowerPoint. So the applications or software that you pull up in your laptop fall into one of two categories. There are network-based applications and there are non-network-based applications. For example, non-network-based. Windows, Word, right? Microsoft Word or Notepad. You open it up, you type something into it, but that program is fully self-contained within your laptop. In other words, that program has no knowledge that there is an outside world out there. There's no component, there's no button you can click in Word or Notepad that says, take this information I'm giving you and send it to the next room or send it to the next country. It wasn't designed for that. That software application was just designed to stay strictly within your memory on your laptop. It's blind. It has no knowledge that there's an outside world at all. Whereas network-based applications connect to a network. Network-based applications have some component built in that says, okay, my software was designed so that I could either pull information from some remote resource, some remote device, or I could push information to some remote device. So a network-based application is aware that there's a network out there. Now, it might not know how big that network is. It might have no idea how many devices live on that network. All it knows is it says, look, in my room there's a door. There's a way for me to get out. And beyond that door, there's other people I want to talk to. Whereas the non-network application just sees a room with no doors. It says, I'm just in here by myself. This is my universe. So, network applications, there are some prerequisites they need to do their job. So, number one, in order for a network application to work, it needs some sort of descriptive name for itself. Right? Now think of this, imagine that you are in a crowded room, right? It's, we just recently had New Year's Eve here a few days ago as I'm doing this recording. And so some of you guys were in really crowded rooms where a party was going on, right? So if you want to communicate to your friend who is across the room, that friend needed an address, a name, right? You couldn't say, hey, how's it going over there? You needed to address it to, hey, Tom, hey, Jane, how are you doing? So that person needed a name, and then you need a name, right? They'd have to shout back to you, hey, Keith, I'm doing good, how are you doing? So same thing here. Any device like your laptop, your tablet, your smartphone, in order to communicate across a network, it has to know two things. It has to know what's my name, what's my descriptive name on this network that makes me unique from everybody else on this network, and what's the name of the person I'm trying to communicate with. Now, in the world of computer networking, that name is typically what we call an IP address. IP stands for the Internet Protocol. The Internet Protocol is a software, it's a code that people wrote a long time ago who are a lot smarter than me, that covers a lot of the details of networking. And for this class, we don't have to know any of that. All we have to know is that one of the components of the Internet Protocol is that it provides an address. When your laptop, when your tablet is running IP, one of the very first things it learns of is its address, its identifier. Now, in the world of networking, that's a number. That's a numerical identifier. For example, let me show you right here what my IP address is. And you're going to be doing this several times. So if you want to follow along with me, all I did right now is I clicked the Start button in my laptop, and I located somewhere in there the little black box that says Command Prompt. And I'm clicking on Command Prompt, which gives me this. All right, so this is what we call the DOS command prompt. This gives me access to DOS commands. And one of the DOS commands you're going to do all the time when you're doing network troubleshooting is the IP config command. So we just talked about what IP is. It's the Internet Protocol. Right now I'm telling my computer, tell me how you're configured for IP. What IP information do you know about in order to do your job? So I type IP config and I see a whole slew of stuff. Well, when I go up to right now I'm connected via Wi-Fi. See right here where it says wireless LAN adapter, IPv4 address, that's my name. So on my laptop's unique name on this network is 10.7.1.237. Nobody else on my network should have this name. This makes me unique. Now, if I tell my laptop, hey, I want you to go to Google or INE or something like that, it's going to have to figure out what the IP address is of Google or INE, which might be 9.9.9.9 or 8.1.77.6, but it'll have to somehow figure out what that name is. Now, when you use a network application like your web browser or emailing, you might think to yourself, okay, does that mean that when I open up my web browser, it has a unique name, it has an IP address, and then when I go to open up my email, that has a different unique name? No, it doesn't work like that. That IP address I just showed you is for your laptop in general. So when your network application opens up, email, web browsing, whatever, it doesn't even really have to know what your name is. Basically, the network application opens up, and then it connects to another process in your laptop. You see, the way your laptop works is that one process triggers another, which triggers another, which triggers another to get the whole job done. So when you open up Internet Explorer, it triggers the IP protocol, which is in your laptop. It's another piece of software that typically you don't even touch, you don't even see. And Internet Explorer will say, okay, here I would like you to do something to get the web page called INE.com. Can you get that for me? Then IP says, in your laptop, it says, okay, I know what my name is. Let me figure out what the name is of INE.com, which is some device out there, so I can send a request to it to get that web page. So, network applications need to use IP addresses. Next thing, you have to have some physical way of connecting to the network. I mean, after all, networking means that your device, your tablet, your laptop is trying to communicate with some other device, which might be sitting 5 feet away from you. It might be sitting 5,000 miles away from you. But the fact is, it's two separate devices. So we need some mechanism to connect to that. Now, that mechanism could basically be one of two things. It could either be via a cable, or could be wireless, right? A lot of times these days, our laptops and our tablets use what's called Wi-Fi, which is wireless networking, which means there's no cable connected to you. You're just using the air and electric magnetic waves going through the air to talk to somebody else. But there has to be some component in your laptop, in your tablet, that connects to that medium, that connects to that cable, or connects to the wireless signals. And that component, that piece of hardware, which you can actually pull out and look at, we call that a NIC card. It stands for Network Interface Card. In other words, how do I interface, how do I connect to the network? So if you have some device that does not have a network interface card, you cannot do networking. There's no way for you to connect to a network. Fortunately, these days, pretty much almost anything you buy, your Xbox, your PS3, your laptop, they almost all have network interface cards built into them, because these days, everything is moving towards networking. Probably 5 years from now, even your refrigerator and your microwave will have a NIC card, so you can program it and do stuff remotely to it. But you got to have a NIC card. Third thing, chances are the device you're trying to communicate with, the Google server, the INE server, the CNN server, probably is not in the same room that you are. It's probably not even the same city that you are, although it could be. So in the world of networking, in the world of network applications, networks are divided into two general categories. There's basically the network I live in, which is, who can I talk to directly, and everybody else. Once again, bring it back to the example of human beings, of people. So once again, you're in a room with a whole bunch of people, and you can talk verbally to anybody in that room. Just open your mouth and speak, and they can hear you. So in networking terminology, what we say is that's called your broadcast domain. Your broadcast domain is all the devices that can directly hear you talk. So for example, if you're doing Wi-Fi, when you send your Wi-Fi out, everything else that's within range of you that can hear your Wi-Fi signal, that's sort of in your broadcast domain. That's in the same local room as you. But bring it back to that human analogy. So I'm in this room with a whole bunch of people, but who I actually want to talk to is my mom, and she's across the United States. Well, if I just talk, there's no way she can hear me. I can't scream loud enough for her to hear me 3,000 miles away. So in networking terminology, that means I have to look for somebody else in my room that I can talk to. I can give my message to that person, and somehow, I don't care how they do it, but somehow they have the ability of giving it to my mom. Now they might hand it off to somebody else, and somebody else, and that message might be handed off to like 20 different people before it finally gets to my mom at the other end of the country. For me, I don't care. All I care about is that my message gets to my mom. I know my mom's not in the same room as me, so I have to turn to somebody else and say, okay, you're the one who's in charge of getting messages out of this room. So let me give you the message. Let me give you the address. It's coming from me, Keith. It's going to the destination of my mom. Those are the two addresses. And I'm going to wash my hands of it and say, your job to send it on its way. So in networking terminology, we call that device a default gateway, which is typically a router. It's a physical box, and your laptop knows about it. So when your tablet first comes online, very first thing it says is, do I have a NIC card? The answer is probably yes. Number two, is the NIC card functional, or did someone spill coffee on it and it's broken? Oh, seems to be working. I'm getting some electricity from it. It's there. It's functional. Then it says, okay, NIC card, do something to give me an address, to give me a name, an IP address, and also let me know who it is in my room, who my default gateway is. I need to know the address, the name of my default gateway. Once you have those two pieces of information, now your laptop, your tablet says, I'm good to go. I can talk to people in my own room, and I can use my default gateway to talk to everybody else. And we'll go into a little bit more details about that process, how it gets all that information. Now, chances are 99.99% of you, in order to get to remote devices, have to make use of an ISP, which stands for an Internet Service Provider. Now, if you're doing home networking, then your default gateway is, probably your laptop is connected to some little black box, which is your cable modem or your DSL modem, and that is connected to your wall, which then is connected to some underground cable or maybe the phone lines, which then go 5 or 6 or 10 miles, and then it ends up in a building owned by your internet service provider. Like for example, me at home, I use Time Warner Cable as my internet service provider. So my DSL modem plugs into the wall, connects to a cable, which is then presumably buried under the ground somewhere, and then pops out like 5 or 6 miles later in a building owned by Time Warner Cable. They have a router right there at the other end of that cable. That is my default gateway. So as a matter of fact, when I boot up my laptop at home, it connects that cable and it goes all the way 5 or 6 miles and talks to that device and says, okay, let me learn about you. Give me your address, your name. And so at that point, Time Warner Cable, my service provider, takes my information and it's their job to send it through the internet, which might consist of going through 20 or 30 or 50 routers, depending on how far away my message has to get. So I just want to make sure you understand that term ISP. And then lastly, the term of DNS. When you pull up your web browser and you want to go to google.com or CNN.com or BBC.com, well, those names are good for us as human beings, right? Google, CNN, WRAL, those are stuff that we can memorize pretty easily in our brain. But in reality, your laptop or your tablet says, okay, thank you for giving me that name of CNN or Google or whatever, but what I really need is the IP address. I need that number of the device. Because just like my laptop has a numerical name called an IP address, it says I need to know what the number, the IP address is that corresponds to the device that's holding on to Google's websites or the device that's holding on to INE's websites. What's that name? What's that IP address? Well, you as a human being, you probably don't know what that is. I mean, how often have you opened up your browser and typed in 75.2.3.4? Probably never have you done that. And yet your laptop needs that information to do its job. That's where something called DNS comes in. DNS stands for Domain Name Server. So when you type in google.com or cnn.com, that is called a domain name. You know, .com, .org, .gov, you know, something.gov. Those are all called domain names. So what you're really saying is, laptop, I'm going to give you a domain name, and I want you to resolve that, figure out what the IP address is that corresponds to that name. And so your laptop invokes another piece of software behind the scenes called DNS. And so your laptop says, okay, let me see, how am I going to do this? Well, let's see, when I first got turned on, when my power switch was first turned on, I sent out a message into the void, into the network saying, hey, is there anybody out there that can give me a name? I need an IP address. Can anybody tell me what that is? And then there was some device out there, it's called a DHCP server, but we'll get into that, but you can write that down if you want, DHCP. There was some device out there called a DHCP server that said, hey, I hear you. Here you go. Here's your IP address, and you're probably going to need the IP address of somebody in your room who can get you to the rest of the world. That's your default gateway. So here's the IP address of your default gateway. And you're probably going to be typing in names of things, and you're going to need those names translated into IP addresses. So here's another IP address. Here's an IP address of a server. It's probably owned by your service provider, your internet service provider, in my case, Time Warner Cable. Here's an IP address of this other device that can resolve those names for you. So when you type in google.com or cnn.com, just send a request to that DNS server and say, hey, DNS server, I know about you. I know your IP address because I learned it when I first booted up. Can you translate this name into an IP address for me? And then if that DNS server is functional, he'll say, oh yeah, here you go. You want google.com? That is whatever it is, 7.9.32.5. That all happens in the background. You don't see it with your own eyes, but that's what's happening. And now your internet browser says, okay, great, I've got the IP address. Now let me go ahead and send my request to that IP address and let that device know, give me your website, give me your web page. So in virtually everything you do, your email, your instant messaging, your web browsing, almost all of them require the use of DNS in some flavor or form. Almost everything in your laptop is configured with some kind of a name, and it has to resolve that name to an IP address. And if you don't have a DNS server, you're stuck. There's no way to do that resolution. Now, once again, let me bring up, you might say, well, how do I see this stuff? Let's just go back to our trusty command prompt again. Now, I previously showed you how to do the ipconfig command. And yeah, DNS stands for Domain Name Service. And so if I go here, now if I just do ipconfig it shows me some real basic stuff. Now notice I see a lot of stuff in here. You might be saying, well, which one should I be looking at? As you scroll through this stuff here, you'll notice that most of it says something disconnected, or it has no reference whatsoever to an IP address. So you're just going to want to scroll up through here and find something that has an IP address. Oh, here we go, my wireless LAN adapter. So IPv4 address, I mentioned already, that is the IP address of me, my laptop, that I learned via this DHCP thing. Subnet mask, not going to go into the details of that. That just basically helps me to identify what room I'm in, what local network I'm connected to. It's sort of there's a comparison that happens between these two numbers to help answer that question. And then default gateway. So there's another device, a router, in my same room, and this is his name, 10711. So if I need to send some message to some other remote network, I'm going to forward my message to him, 10711. But there's a lot of additional stuff my laptop has learned via DHCP that's not shown here. And you can see that by typing ipconfig/all. And this is going to show you a whole bunch of gory details. So once again, let's scroll up to the one that has an IP address in it. There we go. There's my wireless LAN adapter. Once again, it gives me my IP address, my default gateway, and down here, my DNS server. Now, depending on what kind of a network you are on, it may look like this, where your DNS server is showing up as the exact same physical device as your default gateway. Or it might be different. For example, if you're actually working on a company's network, you're not at home, but you're working in some corporate network, chances are these two numbers will not be the same. They'll be different. In my particular case here, in this office I'm in, it's showing me that the DNS server is the same device. Now, in reality, it's not. If I actually went to our closet here that has a little router that's serving as the default gateway, that little router in there, which has the name of 10711, it has no idea what the IP address is of Google or CNN or BBC.com. It has no idea. But that router in turn has a special command in it that says, here is your DNS server. So I'm not sure what internet service provider we're actually using here at my company, but that internet service provider has a real DNS server. It's not 10711, it's something else. And our default gateway knows what it is. So, but instead of giving that information to me, my laptop, I was just told, hey, use that one device for everything. Use that one device that's 10 feet away as your default gateway. It's also giving you your IP address and stuff. And you can also use it for name resolution of Google and CNN to actual IP addresses. Now, when you do this command, once again, it was ipconfig/all. You may see the same thing, where your default gateway and DNS server are the same, or they might be different.